Today we're talking about reference angles, and reference angles are the acute angle formed by the x-axis and the terminal side. So really important, acute angle, meaning it must be less than 90 and bigger than 0 degrees. And it is with the x-axis. So I would say that's the number one biggest mistake that people make is they want to try and say it's with the y-axis. It is with the x-axis. So if we have 120 degrees, okay, we know how to graph that. We know how to deal with that. So we have our XY coordinate plane. We know 120 is going to be in the second quadrant here. Remember, they are the first, the second, the third, and the fourth quadrants. Okay, we use Roman numerals for them. So 120 degrees. We know we use the positive x-axis there. And then if this is 90 and this is 180, we know that we have to be 30 degrees past this. So somewhere about right there. Okay, there's 120 degrees. So then where does this whole reference angle thing come into play? So our reference angle in this, so for 120 degrees, let's step back for a second. We could go this direction and be at 120 degrees. We've also talked about coterminal angles, so that means that we could have gone this direction and had negative 240 degrees. And so we're not exactly sure which way we've gone, and that's okay. Obviously, it could be one of the other coterminal angles with 120 as well, but all of them have the same reference angle. So if we are at 120 degrees here, and we find the fastest way to the x-axis, because it has to be an acute angle. If we went this way, it would be too much. Here, if we're at 120 and we have to get to 180, our reference angle would be 60 degrees, okay? So if we were at negative 240, we would still have a reference angle of 60 degrees. And that's going to be important once we start learning about the unit circle, which doesn't mean much to you now, which is fine. All right, so let's look at another one. So 60 degrees is the reference angle. All right, 330 degrees. So for this, and as you're starting out, you may want to use like an actual graph of things. Once you get a handle of it, you may not feel like you need it at all, and that's okay as well. All right, so 330 degrees, start off with positive x-axis. We know that we're going to go almost all the way around to right here. Okay, so remember this is 270, this is 360, so we know we have to go past that 270 by 60 degrees. And so then if we're looking for our reference angle, it's the fastest way. Well, which way is going to be faster to get to the x-axis? Going left here or going right? It's definitely going to be going right. So if we're at 330 degrees, how much more do we have in order to get to the x-axis? That would be 30 degrees, because 330 plus 30 degrees is 360, okay? So as you're doing this, when we're in degrees, which is what we've done so far, you're going to go to 0 degrees, 180 degrees, or 360 degrees when you're trying to find your reference angle. For radians, we're going to just go to those equivalencies in radians. So 0 pi, pi, or 2 pi. All right, so let's take a look at a few examples here. We're going to do some in degrees, and then we'll do some in radians. Okay, and again, starting off, it might be beneficial for you to graph them to know which quadrant you're in order to know how you're going to find the reference angle. All right, so we have 315 degrees, which we know is in the fourth quadrant here. Again, we're between 270 and 360. Oops, 360. So 315 degrees is halfway in between those. So we're right here. And so then how many more degrees would it take us to get from that 315 to 360? Because going this direction, that's an obtuse angle. We don't want that. So going this direction, if we're at 315 to get to 360, we need 45 degrees more. So that is our reference angle. All right, for negative 83 degrees. So now we have a negative angle, which we know how to deal with. So this is 0, this is negative 90. That means we're almost there to negative 90. Because it's a negative angle, we are going to go clockwise. So we're going to go there. There's negative 83 degrees. So which way is it faster for us to go? It's faster for us to go this direction up to 0 degrees, okay, or negative 360 degrees is also the same thing there. So how many degrees would we need to go? For that one, we need to go 83 degrees. 83 is an acute angle, and it's how many degrees we have to go back to get to the x-axis. All right, what about this one? So we have 127 degrees. So let's work on, let's do this. For this one, I'm still going to graph it, but I'm not going to draw the actual XY coordinate plane. So we know 120, if this is 90 here and this is 180, so this is another way you can do these questions. We know that 127, if that's 90, that's going to look something like that. Okay, so that's 127 degrees. So then we have to figure out the fastest way to the x-axis, which would be back down this direction. Here's your x-axis. So if we're at 127, how many degrees do we have to get until we're at 180? Well, this is where you're going to take 180 and subtract 127. Oops, doing the math in my head already. So 53 degrees is our reference angle there. Okay? So you don't have to draw the XY coordinate plane if you don't want. I think it's beneficial though, so I'm going to do it for this last one, for degrees. All right, so we've got our XY coordinate plane. Okay, we're graphing 742 degrees. We start off here. If we go all the way around, that's 360. That's not enough yet. So we have to go around another time. That would give us to 720. So that doesn't get us enough either. We got to keep going another 22 degrees. Now, your picture, I should have mentioned this before, it doesn't need to be totally accurate. I should not see you like here halfway in the middle or closer up to 90. It doesn't need to be exactly 22 degrees. I'm not going to get my protractor out to make sure you're there, but that's, you know, it should be around there. All right, so we've gone around twice, and then we had to go a little bit more. So here, how much extra did we have to go? This distance is what we need to come back down. So that was 22 degrees. So you could do the math like we did over here, where you're taking, in this case, you would have to take 742, you could subtract 360, and you could keep going until you find your coterminal angle as well, which was 22 degrees. Okay? All right, now let's take a look at some ones in radians. Okay? All right, some people find these easier, some people find these harder because they are radians. So especially with graphing these, I think it's easier to actually look at the XY coordinate plane. So remember, for these, if we have 5 pi over 3, that means that this here is pi, so it's 3/3, and this here is 6/3. Okay, and so we want to go, there's 1, 2, 3, 4, 5, 6 pieces of pizza all the way around this. So we want 5 of them, and we're going in the positive direction. So that's going to be right here. Okay, that's 5 pi over 6. So the fastest way to the x-axis is going to go this direction. If we were at 5 pi over 3, we only need to go one more piece of pizza, if you will, to the x-axis. So that piece of pizza is 1/3 of pi, okay, or pi over 3. Negative 2 pi over 5. So here is where we're going to start. Since we're going negative, this means this would be negative 5 pi over 5, and this is negative 10 pi over 5. So this would be negative 2.5 pi over 5, because that's halfway in between them. right? This bottom part here would be cut into 5 equal pieces of pizza, and we need 2 of them. So we're going to be pretty close down here. Okay. If it helps you, you can draw out those 5 pieces of pizza, kind of how I drew out this stuff. It's kind of up to you. All right, so our fastest way is going to be going up this direction. So how much did we go? We went 2/5 to go down this direction. So our reference angle will be positive 2 pi over 5. All right, 7 pi over 4. So because we're dealing with fourths, we know that this would be 4/4 and 8/4, okay? Which means this is 6/4 and this is 2/4. Okay, and you can put as many of those around the units or around here that makes sense to you to graph this. All right, so we start with the positive x-axis, and we have 7/4. So 1, 2, 3, 4, 5, 6. We need that right there, 7/8 or 7/4. That's halfway in between 6/4 and 8/4. And so this distance right here is what we're going. We're going 1 more piece of pizza up, and that piece of pizza is a 1/4, is a pi over 4, I guess I should say. And so then that would be our answer, pi over 4. All right, last one here. And these questions just take practice. That's why I'm doing so many of them. All right, we have negative 13 pi over 3. So that means that this would be negative 3/3. And this would be negative 6/3. Since it's a negative, we're going this direction. This would be negative 1.5 thirds and then negative 4.5 thirds. Okay, so if we're going negative 13 thirds, we're going 6 pieces of pizza that hasn't made it all the way yet. So then we would go 9, 12 pieces of pizza. We're going 1 more piece of pizza past this. Okay, so we're going to be about right there. So how many pieces of pizza did we go past the x-axis? That's how I like to think about it when we're in radians. And so we went 1 more piece of pizza past it. So in this case, our reference angle will be pi over 3. Okay, so it is an acute angle that goes back to the x-axis. Depending on if you're in degrees or radians, you'll either have pi or not. Okay, that's it.